Okay, Algebra 1 students, this is our video on simplifying expressions and solving one-step equations. And this is still chapter 1 in our textbook. Not going to waste much time on the title slide, so let's get right to it. Let's make a very specific distinction. What's the difference? So we have three terms here. We've got evaluate, we've got simplify, and we've got solve. And each one means something different. Evaluate means, that's when we learned last time, plug in the replacement values for the variables, then simplify to find the numerical value of the expression. So when we say evaluate, you're finding the value of that expression. Simplify means do all the math you can do until you can't do any more. When I evaluate an expression and I plug in the numbers, I then simplify the numerical expression. So I'm doing all the math I can do till I have an answer. And that's what we do with numerical expressions. With algebraic expressions, we will be simplifying until we can't do any more math because it's in simplest form. And then solve, down here, solve means find an unknown value, usually the variable. So they do mean different things. So I'm not really solving an expression. I can simplify an expression. I can evaluate an expression for replacement values. I can solve an equation, but I can't really simplify an equation. I can put it in simplest form, but we don't really say, let's simplify this equation. We don't usually do that. It's usually given to us in simplest form. So, in an algebraic expression, we have different terms, and some of them are like terms and some are not. So the question I have for you here is, what makes two terms like terms? Stop and think about it for just a minute before you continue. But I hope what you said was that like terms have the same variable with the same exponent. It's got to be the same variable raised to the same exponent. So in this expression, 3x squared and minus x squared are like terms because they are the same variable, x, with the same exponent squared, or 2. These are like terms, 2x and 7x, because they both have an x, and because that x is just to the regular old first power. And then we have this one, which is all by itself, does not have any like terms. That's just a... Do you remember what it is? Just a minus 4 all by itself with no variable? It's a constant. And if you said constant, you're doing it right. Now, when we combine like terms, when we simplify an expression like this one, we are taking the terms that are the like terms and we are combining them. So I see here 3x squared and a minus x squared. So that's 3x squared and negative 1x squared. That's 2x squared. Then I see here plus 2x plus 7x. That's a 9x because they're both positive. So 2 plus 7, 9. And we still have our minus 4. So we've simplified it, and there's no like terms left now. In the one that's underlined with the colors, we had like terms, but now because I simplified it and combined those like terms, I have no like terms left. All right, what about this next one? If I simplify this one, what are my like terms? Well, I have an x squared here, and oh, that's it. No other x squared term. Okay, I have a minus x here and a plus 6x. Those are like terms. So they have that same variable, x, with that same exponent. And then let's see, plus 8 and a minus 10. And those are like terms because they are both constants. So we do not have a like term, the 5x squared, so I'm going to leave it alone. We have minus x plus 6x. That's going to be a plus 5x. And then we have a plus 8 minus 10, which is going to be a minus 2. So that's, in simplest form. We have combined the like terms. So now we have an expression that has been simplified. It's in simple, let's spell simplest correctly. Simplest form. All right. So let's practice simplifying some expressions. My suggestion, as always, is that you pause it, please. That you pause it and try them. And I'm going to start running through them now. So if you're going to try them, come on now, pause it, try it out. It's good for you to have that practice. And then you can go through and just watch me do the answers, or you can even fast forward. And if your answers are all correct, you can just move on. All right, so I'm going to start off with this first one, which is 3 times the quantity, x squared plus 4, and then a minus 2 on the outside. I'm going to distribute. The distributive property, you will recall, has you multiplying through a sum or a difference. So multiplying each part of a sum, or in others, each part of a difference, like that'll be down in a later problem. We have 3x squared plus 12, and then minus 2. 3x squared plus 12 minus 2 plus 12 minus 2 is plus 10. So we have 3x squared plus 10. All right, and then down here, we've got like terms, as we saw in the previous problems. N and 9n is 10n. And then minus 10 and minus 3 makes minus 13. Again, more like terms in the next expression. Negative 21p has a like term with positive p, so that's going to be negative 20p. And then there is no like term to go with minus 76p squared, or a like term to go with minus 9, so that one was almost simplified before we started. And then we have more distributive property problems. So number 4, we've got 9 times the quantity 5 plus t, and then minus 6 times the quantity t plus 3. And there's something going on here in the second half that we're going to see is an important detail to pay attention to. So make sure you are paying attention. 9 times 5, 45. 9 times t, 9t. So 45 plus 9t. And then we're going to multiply through over here. Now, minus 6 times t is minus 6t. Minus 6 times a plus 3 is going to be a minus 18. Think of that as a negative times a positive. Negative times positive is a negative. And now I've got like terms to combine. 45 minus 18, that one's going to come out to 27. And it is a positive 27. 9t minus 6t is 3t. And that one is once again simplified. Now, can I make it 30t? Can I? No, I cannot make it 30t. They are not like terms. Please don't try to combine them. All right. Last one of these. We have a minus sign out in front of the parentheses. That's like distributing in negative 1. So that's saying negative 1 times m and negative 1 times 3. So minus m minus 3. And then minus 2 times m minus 2m. And minus 2 times minus 2, which is going to be plus 4. Like terms, minus m and minus 2m is minus 3m. Minus 3 plus 4 is like negative 3 plus positive 4. Minus 3m plus 1. Now, let me go back a step, because I kind of went through this part really quickly there. If you got that right, kudos to you. Fast forward through this last part, and then go on to the next slide. But for a second here, minus 2 times m is minus 2m. That's the same, actually, as what we had up here with minus 6t. But minus 2 times a minus 2 is like a negative times a negative. It comes out positive. So I want us to make sure we are recognizing that pattern. That is going to come up again, and we don't want that to catch us. Next, we're going to move on from simplifying to solving equations, and we're going to look at the 2 methods of solving equations. Now, I almost exclusively meaning almost all of the time, I use properties of equality, and I'm not trying to cross it out. I was actually trying to highlight it, and I did a very poor job. So there we go. I like to use properties of equality. I think it's a better method in my head, as you will see later on in the video with more problems that we're working on. But I'm going to show you 2 different ways to solve equations. So you do have properties of equality, then you also have using inverse operations. So with this one, we're going to use inverse operations. We have 15 and 9/10 equals r plus 27.3. We have addition in the problem, and what I'm saying when I say inverse operations, I'm saying let's take the plus 27.3 and make it a minus 27.3 on the other side. And that's one way to look at solving equations. Now do the subtraction, you get negative 11 and 4/10. And that is the correct answer for r. So that is a way to solve equations there with that inverse operation. If we use properties of equality, that is where we are going to put our line down the center and line across, and we're going to use the opposite operation that we see. We see plus 27.3. We're going to subtract 27.3 from each side. Canceling here, leaving me r equals, and the difference of two numbers is 11.4. And those operations where we are treating both sides the same, those are called properties of equality, like it says above. I'm not going to write it out again. Why would I write it out again? Because we are doing the same thing to both sides. So it's the same thing done to both sides, which you will see in the examples on the next slide. So let's get to it. All right, 4 examples. This time, instead of taking all that time to write through, I'm going to go through and solve them while paused, but I want you to pause it and try them yourself. Yes, there's some ugly fraction and decimal math here. So part of what I'm doing right now is seeing, well, how well do we remember this stuff? And yes, you will see a little bit of ugly fraction and decimal math in class. Pause it, try these 4 problems, and then continue so you can see how you did. Okay, make sure you pause it at this point. No turning back. And here are 4 solutions. So I chose mostly to use properties of equality. The properties of equality method, where you're adding or subtracting or multiplying or dividing the same way on both sides, appeals to the way my brain works. So for 2, 3, and 4, that's what I did. And I want to run through those first. 9/10 times c equals 11 7/10. I automatically, when I see a coefficient times a variable in a one-step equation, I automatically put in my fraction bars, divide off the coefficient, and I'm done. Also, remember with your decimal math, you don't need to reach for a calculator every time. Challenge your brain a little, folks. They're both decimals with 1 decimal place, so I multiply them both by 10, not changing the value of the solution, just making the division easier. Then I just use what I call short division. 9 goes into 11 one time, with 2 left over. 9 goes into 27, so like the leftover 2. Sometimes I even write it right up here. So the leftover 2 makes 27, 9 into 27 3 times, and that's my solution. Number 3, 3/4 n equals negative 3/8. This is the type of equation where you want to use multiplication to solve. Multiply by the reciprocal. You multiply by the reciprocal, you get rid of the fraction, and in many cases, you already have a fraction here anyway if there's a fraction coefficient, so it's easier math to multiply 2 fractions. Simplify and you have your answer. Number 4, negative h over 7 equals negative 18. What I want you to remember here is that we can see that we're solving by multiplying to get rid of this division we see here, but usually the question is, what about this? Well, let's think about if we multiply by a negative 7, that's automatically going to give us what we want because negative times negative is a positive. The 7s cancel each other out, and negative times negative makes it a positive h. And it appears that I did not finish that problem because I did not multiply 18 times 7. Well, negative 18 times negative 7, we know we have a positive answer. So that's going to be 10 sevens, that's 70. And so 10 sevens, that's 70. And 8 sevens, that's 56. So that's 126 is my answer for that one. Now, going back to number 1, I chose something different with this one. So for this one, I decided, well, I'm going to take that minus 4 3/4 and make it a plus 4 3/4 on the other side. And it looks like my plus sign got a little bit cut off there. Let's fix that. And then I just got my common denominator, added my fractions, had to rename, and got a final answer. Now, you will be amazed to see what your graphing calculator that you get to use in class can do with fractions, but until then, yes, I expect you to write out your math. It is, after all, math class, and I will see you next time.